Hi, good afternoon. My name is María Pantoja. I'm here to present this paper, Natural Language Processing for Predicting Successful Legislation. This is work by my master student, Sanjana Gundala, and we are at Cal Poly, California Polytechnic State University, the Computer Science Department. This is the index that we are going to talk first about why and what is the problem we are trying to solve. Previous work, some implementation some implementation details, and then results and conclusions. Okay, so the problem statement, legislation meetings are integral part in lawmaking especially for state and local bills. There are, every time that there is these legislation meetings happen, there are testimonies presented for and against the bill. And these testimonies are not only done by the legislators, they can be done by the general public and lobbyists. And lobbyists are people that are actually paid by certain organizations that want to be represented on these meetings. So they hire some consultants, but for this specific task. The purpose of this work is to build upon the Digital Democracy Project, which is a big project that we have at Cal Poly. Which goal is to increase government transparency and to provide a software platform that will help citizens and lobbyists and legislators, of course, understand the legislation process in the US. In this paper in particular, we want to be able, the goal is to actually find out which sentences and analyze the testimony, which are the sentences that the people that present the testimony make the bill successful. Right, and to be able to do this unbiased, removing as much as we can all the different biases. So we only analyze the testimony presented by general public or lobbyists. So we don't use the legislators' testimony because usually they belong to a party and then they vote for or against the bill. Just because of the party they belong to. So to remove that, we concentrate on testimony presented by people, general public, sorry, and the lobbyist. And why is this tool useful? It may be useful for lobbyists and general public to actually, when they go to present testimony, they will know which sentences and the structure of the testimony is beneficial to bill or to pass the bill or to actually make it fail. And also for the legislators, because it's a tool that will allow them to remove any sentiment and bias from the bill. From some previous work, as I said before, this is actually, this project is part of a much larger project that is called Digital Democracy. In here you have a webpage, a link to the webpage with all the information. This project started collecting data, which is very important, right? So it consists of a very large data set of bills, legislator information, geographical information about the districts, donations, donor information. All of it is publicly available, but we created the database, the centralized database that will make finding this information easier. The initial task for this research was to predict the breakdown of a build according to different criteria, such as does the gender of the testimony, the people that give the testimony, influence if it's positive or negative, rural versus urban, and ideological splits. These are the implementation details. So we like I said, every machine learning project is always going to start with data set, right? And that's the initial years of the digital democracy, is to actually grow and collect this data set. The next step is to actually filter the data set, get rid of punctuation marks or certain words that are very local and they don't provide any information that should be covered, like names of companies and things like that. Details of how we actually filter the data set, because it gets a little bit long, we actually put it on the article, right? But there is a lot of filtering, just unnecessary information, redundancy, and so on, that we clean out of the data set. Once we have the filtered data set, we applied 3 main different kinds of models. One is the feature extraction, the one that you see in the center. So we do feature extraction, create the feature data set, and on top of this, we apply feature extraction models like naive Bayes, multinomial naive Bayes, support vector machine, and FCNNs. We also applied, so all of these models, these 4 models we implemented, we also applied the state-of-the-art of natural language processing, which is based on transformers, and we are using BERT as a base for this. So we also applied deep neuronal network techniques, and we also have this TF, IDF, and then we compare all these models and see which one provides the better accuracy. And by that we mean which ones predict better if the data set, the testimony provide a for, against, or neutral testimony. Sorry, I'm going to repeat it. So all of these models, the goal is to analyze the feature structure, or directly the data, find the pattern, to find out if just by analyzing the test of the testimony, we can predict if the testimony is for, against, or is neutral for the legislation. This is talking a little bit about the beginning, right? The digital democracy research team actually created the data set, and they have a script, they have written a script to automatically transcribe from video to text files. And then once we have these text files, they are actually labeled, timestamped, and aligned. And they add labels, what is the speaker names, for example, timestamp, when did they happen, alignment, if it's for, against, or abstain, and some other information is added to the transcript of the videos. All of the data set is actually stored as a TSV file that then can be actually processed by software like Pandas. The alignment field is the one that we are interested on this particular project, because it's the label that we need for this kind of supervised learning, that we provide the test, and manually people already said, oh, this testimony is in favor or against or neutral. So there are many different feature extractions, and some of the things that we also add to the files, the JSON files, is we applied some readability tests. There are 3 of them: FLES, GANIM, and SMOG, to actually analyze the complexity of the test. This is actually an example of a testimony. So this is the test of the test of the testimony, and this is actually in this paper all the features that we actually extract and the values that they get so you can get a better idea of what the initial step, the feature extraction step is. Like I said, the implementation, then we actually implement the common NLP, natural language processing algorithm, starting by the feature extraction like naive, SVM, and TF-IDF. And going to get into, and they are explained in the article, but I'm sure if you are familiar with them, if you are if you are doing any kind of research in NLP, in machine learning in general. And the last one that we present is that we also apply BERT, and BERT is a deep neuronal network based on the transformer architecture. They are in the last, I will say, 2 to 3 years, BERT and transformer-based natural language processing models have been outperforming everything else. So they are considered state of the art, these transformer-based models. So I'm going to present the results. So this is, again, I have all the results and the entire list of all the sentences that are important, or the model decided that are important to determine the alignment of the testimony. Here is a small list of them. So again, you have a better idea of what makes a testimony, for example, what words can be extracted from a testimony that determine that it's going to be against its opposition to this measure. For example, this sentence, if you have that sentence, you basically know that the testimony is going to be against. Some of them are actually, this one was very obvious, but some of them are actually a little bit like less obvious to see. This is the correlation matrix of all the different feature extractions that we are using. And you can see they are all over the place, but there are some of them, like, for example, this average sentence length, and no, I cannot see it, but the complexity of the test is very clear that the shorter, the shorter and easier to understand tests have a much better success rate. This is also a table because we have so many models, right? So this is a table that summarizes all, and we did 3 trials for each one of them. And this is the accuracy, precision, recall, and F1 for Gaussian, multinomial, SVM, and neuronal network. And if you look at the accuracy, very clear that something as simple as a Gaussian naive-based Gaussian model actually has a really high accuracy. The deep neuronal networks didn't do that well on the prediction. We are still working on them, trying to make them better. Do a different feature extraction maybe works better for them, but with a 90, 95, 90, 91, 92% accuracy on a very simple model like naive Bayes, is basically saying, we have a solution, let's make something more complex. It takes birds and these transformer models, they take longer to execute and analyze. So maybe it's not worth it. And just a naive base give enough accuracy for the project. As a conclusion, we research natural language processing and machine learning techniques, different ones, to analyze testimonies on the California legislature to determine what aspects of the testimony makes the legislation successful. We did use feature extraction and classification models with analyzing these features. And we actually identified some of them that provide really high accuracy, above 90%. Yeah, this is using specific phrases and shortening the sentences and make it less complex, clearly aid the testimony success. So that's an important conclusion. And I think I mentioned this, but it's worth to mention it again. So something as simple as a naive base gave 90% accuracy. Deep neuronal network, the simple one, the fully connected neuronal network, it was around 70% accuracy, and BERT was around 80%. So we still are improving the transformer model and see if we can actually beat this 90%. But by now we do have a model that with 90% accuracy predict if the testimony is going to be successful or not. And with this, I finish the presentation. I will be present during the conference, the online presentation, so you can ask any question. Thank you so much.